Hello, this is Mr. Tolbert's Physical Science class. This is Chapter 10, Section 2. This is Lesson 4, and on the current note packet, guided notes that we are, it's about page 14. Lesson 4, page 14. What is temperature really? Atoms are in constant motion, even in a solid object. The back and forth jiggling of atoms is caused by what we call thermal energy, which is a kind of kinetic energy or kind of movement. When you are sitting back and jiggling, that is actual movement. So this connects us to the state of matter being a representation of how fast or slow matter is actually moving, which is also its temperature. The slower it's moving, the lower the temperature, the more likely it will be a solid. And in most solid cases, the atoms are right next to each other, tight packed, very cozy, but they're still humming and shaking. Temperature measures the kinetic energy per molecule due to random motion. Remember, folks, temperature basically is the speed limit. So if you're going really fast, it's a high temperature. If you're going really slow, it's a lower temperature. And in that, it creates this, what they call intermolecular forces. Intermolecular forces are the attraction for atoms to each other. The slower that they go, the more attraction they're going to have because they have more time to pull on each other. The faster that they go, there's less time as they whiz by each other to pull on each other. Thermometers. Now, a thermometer is an instrument that measures the exact temperature. Most thermometers back in the day contained mercury. You should never, most of you guys have probably never used those types. However, you may have seen the red fluid type, which is actually alcohol and some red dye. Kind of looking like this here. How thermometers work. In the very bottom of the bulb there, you have this dye in alcohol. And it's pleasantly just kind of sitting back, holding its ground. As you increase the temperature, those molecules of whatever you put it in start impacting the size of the container while down there where the bulb is. So all of these impacts are going to eventually be moving the little alcohol and dye molecules around. As they move around faster and faster, they start to line up and take up more space up the tube. The liquid alcohol expands to take up more space in the thermometer. As they expand up, we register that as a temperature. Now, most of you are used to what they call thermistors, or you're used to some type of digital thermometer. And a thermistor, you need to know this, is a device that changes its electrical resistance as temperature changes. And digital thermometers sense temperature by measuring the resistance of flow, resistance of the electrons passing through the wire. We'll be also talking today about what is this resistance to flow. This resistance to flow is basically viscosity, and they're moving at a certain pace because they're attracted to each other, and as they move faster and faster, there's less of that intermolecular forces being shared. If you've ever seen liquid crystal thermometers, they contain crystals that change based on the temperature. As the temperature goes up, the molecules of the liquid crystal bump into each other and change, thus having light reflect off them, giving us different colors. Okay? If you've ever had a mood rings change color based on this. Not necessarily based on your emotions, but based on the temperature of your body changing those little crystals inside the mood ring, giving us different colors. Absolute zero. Really cool. Absolute zero is negative 273 degrees Celsius. This is the temperature, theoretical, that supposedly all motion has stopped. So if we're going to equate temperature with movement, even jiggling is movement. So the scientists decided, well, why don't we get down to where there is nothing moving, and we'll call that stop. We'll call that absolute zero. And that's what this is at, negative 273 degrees. And this is the last one for this lesson. Viscosity. Viscosity is the resistance of a liquid to flow. You're most likely know about it because pancakes and syrup. As you try to get the syrup to ooze all over your pancakes, if the syrup is cold, it's not moving very fast. But if you take that same syrup and warm it up in the microwave for a few seconds, it flows easily right over the top of your pancakes, and you can have your delightful breakfast. Viscosity is determined by the attraction between particles in a liquid. Both liquids and gases can spread. Both liquids and gases are fluids. You need to know that. Liquids and gases are considered to be fluids.